Hello and good evening or good afternoon, everyone, where you're joining from. So we are very happy to welcome you on this webinar. In this, we are going to cover the software-defined storage. So as you know, this has been part of this is a part of a webinar series in which we have been going over different building blocks of the cloud. So, and today we're going to cover that SDS part. We'll just give it a couple of more minutes, as still not 7 p.m. in India time, and then we'll get going. Yeah, so just give us a few minutes before we start. Meanwhile, maybe we can just get going with few questions now that would help us understand the audience better. So let me just put down the poll on the chat right now. So as people are doing the responses there, let's just wait for a few more minutes before I publish it. Okay, so interestingly, this time all the participants have experience of 10 plus years. So basically, it's going to be like a very interesting one. So let's, guys, please submit the poll if you can see on the screen. There's going to be poll on the screen now. How much experience do you have in the industry? Please feel free to fill that up. Okay, so with the experience, with the whatever the polls we have got participants. All of them are 10 plus years experience in this particular webinar. So that's very interesting. But I see that I know some of the people are not 10 plus. So hopefully, I think you could not sign it up. That's okay. So we'll get going. Let me just quickly share the slide and then we'll get going. Let me see if I can ask one more question. Okay, let me just share my stuff and then we'll get going. Share slide deck. Okay, great. So I hope you can see the slide deck, what I have on the screen here. So as we know that this is, in this topic, we're going to cover software-defined storage. And this is a part of the 10 webinar series to kind of cover all the building blocks of the cloud. So we have started this webinar series sometime in March. Then, of course, we took a break. But then now we are doing every month at least one or two if we can, and then try to answer the question how we can build our own cloud. So, of course, if you're using AWS, Azure, and so on, perfectly fine because you can use their tools, you can use their commands to build that up. But there's always a question that how things are happening behind the scene. And from this webinar, that is this series, we want to answer that only, that how we can kind of cover all of these building blocks, and eventually we would see how we can build that entire self-hosted cloud here. So we already have the speakers for all the different webinars as well, along with today, of course, which we'll be kind of doing today, right? Yeah, so this is the agenda of today's webinar. We'll kind of start with how we used to get the petabytes of storage like 50, 20 years back, why we need SDS and what it is, of course. Then consideration, so whenever we kind of uh, choose any storage software, what are the considerations we have to kind of take into account, or the benefits of SDS, the solution. It is on how we can deploy SDS on the cloud and how SDS works with containers and Kubernetes world. That is also we are going to cover. And then what are the next steps we are going to check out as well. So I'll take the first part of the webinar and then we'll have Sanil and Sushanth to kind of take over the remaining part of it. So yeah, so I'll I'm happy to welcome Sanil on our webinar. He is founder and CEO of Caze Labs, and you can see on the screen that he like we can't. It's so much of things to mention about Sanil. He has been. I mean, I think he can kind of talk about himself. That would be better. So that it will do good justice for um, his uh, his uh, his work, what he has been doing. Yeah, go ahead, Sanil. You're on mute, Sanil. Sorry.
Yes, I was on mute. Thanks. Hey, thanks, Nitendra, for this opportunity for us to come and join for your webinar series. You are doing amazing. I think you started from May or March.
Yes.
So, uh, good evening to all of you. And yeah, I think I don't want to go through my experience. I think you can meet me at Sanil Kumar at LinkedIn. I've been working in open source and cloud native space for quite some time. And recently, a new adventure started. We started a company called Caze Labs. We are primarily working on cloud native space. And I'm also part of Soda Foundation, where I'm leading the technology part of the Kubernetes based data management. Yeah, back to you, Deependra. I think you can take it forward.
Sure. Thank you. Yeah, so just going to talk about myself as well. So my name is Nipendra. I'm founder of Cloudiga, and we train companies, employees, and individuals on containers and Kubernetes. I published a book on Docker very long back, and then also authored the first Kubernetes intro course as well for the CNCF. Yeah. So with that, we'll just move on with the today's topic. So first of all, let's look at how we can get the storage, or for example, if you have to get petabyte of storage 15, 20 years back, how we would get it, right? So some of you may have heard the term called SAN, Storage Area Network, which used to be like very big storage boxes, and they used to give the storage in petabytes or maybe further on that, but they have been very expensive. So I just picked up this particular news article from 2005, and it says that now EMG debuts petabyte size storage array. That is whatever, like 18 years back, something like that, right? And then if you look at the kind of costing of it, it starts from $250,000 and can go up to millions of dollars depending on the configuration. So this is the kind of as a minimum you have to spend, but it would go into millions of dollars, which is way too expensive, right? And of course, because of the technology space, it was expensive. But even that, if you look at getting the proprietary software from the big companies like Dell and EMC, so EMC was alone earlier, so it is going to be very expensive, right? Because they have proprietary software and they kind of do all of these things on their own. So from there, we move to software defined, like everything software. So rather than basically having um, do things on only on the hardware level, uh, like so we want to kind of move to the software level. So the idea is that rather than kind of building those big boxes, we would kind of take up our regular hardware what we have. So of course, as you can see here, there's one example of physical SAN which has multiple disks attached to it, and then we can also expose into the software world. But the interesting part here is we have the servers. So we can pick up any regular hardware which we use. We can attach as many disks we want. So as you can see here, it's a combination of hard disk SSDs. So these are your typical boxes, server boxes, what you can get from the out of the basically in your buy from any vendor and so on, right? And then you kind of use the software like Ceph, Gluster FS, and other software which are there, and then you can kind of combine the storage from different servers and expose them as one single unit. So for example, if you have 500 GB from one server, 500 GB from other server, we can combine them and expose as one um, terabyte of storage to the application or whatever we are deploying, VMs or whatever there, right? So software defined storage simply means that you are taking care of storage at the software level, combining them and bringing all the features what you need at the software level itself. So let me show you that some of them. Yeah. So now what are the consideration you would be requiring when you are deploying the storage at scale, right? So you will require the feature of access modes. So of course, when you share your storage, you don't want the storage to be shared in the read-write mode to everybody. You would kind of give it uh, in read-write to some machines or some applications. To others, you would give only the read access permission and so on. So we need that kind of requirement we would be having, right? Then you would require the volume expansion. So if I go back to the previous slide deck, let's say today I have bought a storage of, let's say 500 terabyte. So I have bought a physical SAN of 500 terabyte. Now I want to add 500 terabytes more, correct? So now in the physical SAN, they may give you additional slots. In that you can put your hard disk and expand it, correct? But so that way, of course, you can go up to a certain level. After that, you would be bound by the number of sockets you have here. But if you're going in the software level, you can just add more servers and you can keep going in, add more storage as you go forward there. So we need a feature of volume expansion. Then dynamic provision, we want to get the storage as you would wish. So for example, if I'm deploying an app that needs 10 GB of storage right now, so I would get that storage of 10 GB right now on the fly. So I want to get that. Then I want to get a feature of backup and recovery, right? So I should be able to take snapshots. So before doing an upgrade, so for example, today you have deployed database on your storage, whatever is there, right? And now, before you upgrade to the new version of whatever the software, what I will do is I will take a backup of the current version so that I can uh, recover it if something goes wrong. So we can take snapshots or backups at the storage level itself. So of course, you can take the backup of doing the copy paste stuff and so on, but at the storage level, these backups can be much more faster. Then you want to provide the storage with respect to the block file object storage. So we want to access our storage as a block device. So like when we attach a hard disk to a system, we get like SDS, DB kind of a thing, right? So when I want to get the storage from this SDS provider, I want to get it in terms of the block device or a file access like a typical file system or a S3 based of a storage there. Then I want to even get ephemeral storage whenever I need, I would use that, and when my work is still, I want to remove it. So I want to even get that kind of features there. Then flexibility of choosing a provider. So I can be on any cloud provider, AWS, Azure, and so on. And I would want to still access or configure my storage irrespective of the environment I'm in, correct? So all of these things are should be taken into account when we choose a solution there. Right now, why we kind of should be using SDS, because there is no hardware vendor locking, so you are not bound by the any provider like Dell or EMC, whatever the company is, Hitachi there, right? You are not bound by their offerings. You can just bring your machine and keep going forward, right? You can program your SDS. You can provide different kind of access. It's more cost efficient and automation can be done there. So all of these are benefits of the SDS there. Now, there are different ways by which SDS can be configured. One of it is hyper-based system, hypervisor-based system. So think about, of course, all of you have heard about VMware, right? They can give you the instance with their hypervisor and so on. Similarly, what we can do is we can have like some kind of a control software on that hypervisor, and that hypervisor can manage the storage available on the system and assign to your machines what you are doing. Then we can create the SDS based on containers. Um, then there is hyper converged infra as well. What does it mean? That we are going to think about your building your own cloud with the facility of storage, network, CPU, and everything within a box. So basically, you buy these boxes and keep adding them, and you can start expanding your cloud by giving different services. So this is also very popular right now. HCI based solutions there. That's all I think I have from my side at this point of time. Let me see the questions are there. How about latency? Could you shed some light on this? Um, so latency with respect to the storage, I believe you're getting, right? Of course, because if you're going to access the things over the network, right, there going to be latency. But again, depending on what is the channel, right? So for example, if you are using the 10 gig Ethernet channel between your offerings, right, then it would be fast enough, right? So just 1 minute, sorry. Yeah. So if you are using the channel, the enough bandwidth, which with the channel what you have, it's going to be decent enough, right? But of course, if you are using the fiber and either, I mean, even higher level, there are going to be some kind of challenges. But overall, the cost benefit when you get, you will see the benefit of SDS is much more than what you're talking about in terms of the physical SAN there, right? So of course, as you increase the connectivity between the two endpoints, the SDS software and SDS providers, like in this case servers and your applications, right? If they're interconnected very much, it's going to be negligible, I believe. Yeah. Okay. So with that, I'll then share my screen and then let uh, Sanil share the screen. Go forward. Yeah, go ahead, Sanil.
You're able to see my desktop?
Yes, we can.
It's visible, right?
Yeah, all good, all good.
Hello?
Please go ahead.
Okay. Okay, so thanks, Nivendra. Nivendra was talking about all the basic stuffs about what is SDS and different types of SDS and how really it works, right? So now we'll see some of the SDS solutions, and then we move on to container cloud, and also we'll try to see something really working, right? Okay, so SDS, like Nipendra mentioned, it actually abstracts your application to the storage. There are a lot of advantages with this. Of course, this question about latency. If you see today, most of the vendors, you can see some of the vendors I have put on the slide below, like Dell, Pure Storage, or OnTap, or any organizations who are working on storage. They all have one or the other way SDS solutions because it's need of the hour, and most of the solutions are deploying that. Because of this development, basically the latency is very close to the bare metal storage, almost in the sense it's very negligible that people don't really care because that's the kind of the speed at which the interfaces are performing. Having said about these vendors, storage vendors, there are many open source SDS solutions, very prominent, deployed in different solutions. Like one of the top one is Ceph. It's an object storage. Plus, it also support block and file storage. I hope you understand block, object, and file. Nitendra also just mentioned. Basically, object is kind of flat. It's like a storage pool, and file is kind of in Windows, it's a hierarchical kind of organization of file names and metadata based on metadata, right? Folders and files. And block is something like each block can be differently addressed and it doesn't need to be together. So the file or the object is divided into small blocks. So similar to Ceph, there are different solutions like ClusterFS, it's scalable network file system. TrueNAS is based on FreeNAS. FreeNAS is an open source storage appliance. LinStore is a block storage. It's based on the SDS by Linbit. Then OpenStack, as such, OpenStack provides a lot of abstractions on compute storage and network, like Kubernetes. on enterprise world. So they have Swift, which is a distributed blob store. And MinIO, today we will be seeing MinIO, how it's working, and Sushanth will be showing a demo for us. It's a high-performing S3 compatible object store. S3 is becoming very common these days. Though there is a fight between S3 or file or block going forward, which will win. I mean, that's a challenge. But S3 and object, along with file, is taking more and more lead going forward. Then you see Swift Stack, which manages data at scale, because especially for AI/ML kind of applications. And then one more Soda Foundation, where we are also working. We are maintainers of Soda Foundation project. It's an open source foundation under Linux Foundation, which we deals with open data framework. We have multiple projects on data management. It's completely open source, similar to GlusterFS or Ceph or MinIO. And most of these, today, if you see most of SDS solutions, it will not be just one product or one project, because it comes with different kind of projects. So for example, Pure Storage or Dell EMC or Hitachi, SDS solution as such, if you see, you will see multiple kind of products. Some will be highly performing, specific to AI/ML kind of a data, use cases, or it may be for big data use cases and things like that. Okay, based on the performance. So, like Nipendra mentioned, it's like cost versus performance versus the features, right? That's how the overall SDS solution works. Now let's see very simple manner how really it works, right? So we mentioned that you have an application, you have data, and you have SDS software defined storage, which talks to the storage. Okay. Now application can be, say, WordPress. WordPress application can have different kind of media files, photo or photo, video, or any other files. And now you basically what you want to store this data and retrieve, right? You need to store this data to somewhere, and then access it, modify it, keep it back, or retrieve it whenever you need. So usually you use a persistent storage like hard disk or arrays, flash array, SSD, things like that. Now, between this application and storage is where SDS sits. So MinIO is one example, and the storage can be S3. This is example on the left-hand side. It's an example like WordPress media files, which is written to S3 or kind of storage, the actual storage through MinIO kind of software-defined storage. So basically, software-defined storage primarily give kind of storage with virtualization, and then the data management capabilities, like Nipendra mentioned about access, snapshot, backup, deduplication, things like that. And of course, there is one more key point, is the orchestration part. See, because container, cloud, and different kind of use cases are there. So the orchestration of the storage pieces, whether it is block, file, or object, it needs to be orchestrated in the right way and at scale, right? So that is also a key aspect of any SDS solution. So this is just to scare you. This is a landscape of container landscape. Why I'm showing this is that the container application deployment is exponentially growing these days. I mean, last few years it is catching up, and it's almost getting closer to the enterprise world. The container-based application deployment. So most of the survey says that it's exponentially growing, and 80 to 90% in production container-based application deployments are happening. Because of this, we also need to be paying more attention to container storage. That's why I just showing this. So container storage landscape is also growing. There are so many projects. This is only from CNCF landscape. I have put the links there. These are all storage software which can help you to manage your data. It can be for orchestration. It can be for a very specific type of storage, like MinIO is for object. Zenko is an object storage. Maybe Linbit or Linstore is a block storage, something like that, type of storage. Or use case level, say for example, Edge or this kind of applications. Or container attached storage like OpenEBS. So there are different kind of softwares coming up. The softwares are coming up primarily because, especially in the container space, primarily because more and more container applications are getting deployed in real production scenarios. So this is again, I'm just mentioning, SODA is also part of the CNCF landscape. It is a project under Linux Foundation. We have multiple projects under that. Okay, so when it comes to container storage, there are different terms. I mean, at times it can confuse you. Probably there can be a webinar on each of these terms later. The cloud native storage, CNS. I mean, it's an umbrella kind of a word. This is more related. You can actually compare with software-defined storage in enterprise world, primarily API driven, and the provisioning for a scalable application for storage can be done through CNS. Now, container storage is again, CNS is one type of container storage. It has got declarative APIs, auto healing, and it's scale up, scale down, and all these things can happen. Now, the most important thing we need to know in container world for storage is container storage interface, CSI. So CSI is a specification. It's not a software as such. CSI, when you say CSI, is a specification. Specification says that how do you write the storage APIs for Kubernetes. Okay, so there is a specification available, and most of the storage vendors, if they can comply, their storage drivers are compliant with the CSI, it can seamlessly work with Kubernetes kind of deployment. They are workload deployments. We'll see some more details in the subsequent slides. So this helps for any container orchestration engine. As you know, Kubernetes is one type of container orchestration engine, like Mesos or Cloud Foundry. All these platforms are container orchestration engines, but Kubernetes is the prominent and top one today. So the cloud native stack looks like this. So you have business applications, application platform, and you see container orchestration management. The container orchestration engine is where Kubernetes sits in this layer. Above that is where your applications, your database, your business applications, and things like that. And below, if you see, there are three pieces, right? Okay, let me mark it. So there are three pieces in every container. That is storage, runtime, the compute part, and the network part, CNI. Now, CSI is what our interest is. When you deploy any workload to Kubernetes as pods, it talks to the storage primarily through CSI. Of course, there are solutions talking to storage directly through other SDS solutions, also can work with Kubernetes, but primary interface for storage control plane is CSI in Kubernetes. Now, like I just mentioned about control plane, right? So you have workload, then you have the orchestration engine, and then you have the control plane interface. What is control plane? Control plane is all the management aspect of it. You want to take a snapshot. You want to orchestrate. Say I want the volume to be orchestrated for my application. All these control activities or the management activities will be done through the CSI part. And the data access through the direct interface, any file system write, read, and all these things will be done through the direct storage part. Now, as I mentioned, CSI is a specification, and there is a repository. You can Google CSI drivers. Repositories are available. Almost all the vendors today, including even SDS or the bare metal storage hardware, all those people, they have CSI drivers for their storages. Why? Because Kubernetes is getting deployed widely, and they need to work with Kubernetes. So there are a lot of CSI drivers available. For example, if you have LVM CSI driver, you can simply use that for testing on your laptops. Kubernetes CSI LVM to write your disk and then do some experiments. You don't need any other external storages to do that experiment. Your hard disk in the laptop itself can work that way. So similarly, there are a lot of, Ceph CSI driver is there, NetApp CSI driver, IBM, all these vendors, they have CSI drivers to work with Kubernetes. Now there is one more, which is called container attached storage. It's basically software that includes microservice-based storage controller that are orchestrated by Kubernetes. In the sense, it's just like pod. It's again one more container. This also abstracts all the application, because the Caze also will have CSI. Okay, so basically the application pods will talk to this container only, the container attached storage. So there are examples like OpenEBS. There are good demos available on the web. OpenEBS, Storage OS, Portworx, Longhorn. Longhorn is very popular. It's becoming very popular these days. This is another one. Probably Caze also is a good topic for a webinar if people are interested in storage. Okay, now coming to the cloud part of it, SDS on cloud. Before we get into the cloud part, today, these days, everything is as a service, right? AAS, as service, right? Even compute as a service, disk as a service, network as a service, or blockchain as a service, mail service. Everything is service today. So similarly, storage is also becoming as a service by the advent of SDS solutions and distributed storages and things like that. So storage as a service, right? So this is already there. I think Amazon has all the public cloud. They have one or the other way the storage as a service availability. Even Amazon provides object. I have only put S3 here. S3 file service, block service. All these things are supported. So today, if you want, say for example, a storage, you just need to buy the service and you can just attach to your application and start using it. You don't even know that where that, which vendor, which this thing. So you just define that what service, what kind of SLAs you want, and accordingly you can buy the service. So storage as a service. Now, what is CSTAS? This is like container storage as a service. So for example, you have deployments in cloud. You want container storage for your say Kubernetes deployment on premise, right? We will talk about hybrid later. But suppose you have a cluster and you want the storage service from the public service, public cloud or private cloud. Container storage as a service also becoming more popular, and there are solutions becoming prominent in the space. Now, before I get into the challenges and what next, maybe we'll see really working. We have been talking, Nitendra and me, talking about SDS and how container storage working and things like that. So now let us see how it is really working. So Sushanth will show us a demo based on Minayo. He's the CTO of Caze Labs, and he's also a maintainer at Soda Foundation. And thanks, Sushanth, for joining and preparing this demo for all of us. So I stopped sharing.
Yeah, okay. Am I audible?
Yes.
Hello? Hello. Okay.
Yes, Sushanth.
I can share, right? You can see my screen?
Yes.
Yes, we can.
Okay, good. Hello everyone, good evening, and thanks for joining this learning session. I think looks like most of you have been joining from earlier webinars itself. So Sanil and Nipendra, they have given they've thrown light about what is SDS, what are various kind of SDS available. So we kept one hands-on, one demo to see this. Hello? Hello?
Can you duplicate your display so that it will be visible fully, right?
It is not duplicated.
I am seeing in this thing. Yeah, now
1 minute.
you can go to presentation mode, I think. Yeah.
Okay, just a minute.
If you go to presentation mode, I think it should be
fine.
That's good. It's good. Yeah.
Okay.
Thanks.
Okay. Give me a minute.
It's already on. It's just alt tab.
Yes. Okay.
Yes.
So let's go to one of the, very easily understandable and simply deployable SDS solution, and that is Minio. So what's Minio? It is like it's a distributed object store system, object storage system. It is S3 compatible. S3 compatible. When I say S3 compatible, means S3 is a standard for managing the object store. So when I tell S3 compatible, that means this software will be able to operate on any of the object store systems with respect to any kind of operation. And it's a software design defined storage, and it's 100% open source. That means you can go through its GitHub and see the entire code of Minio and documentation, deployment guides, user guides, everything. And it can be deployed on different platforms. Like it can be deployed on your standalone machine, or it can be deployed on like a container based application. It can be deployed on other container orchestration platforms like Kubernetes or other cloud platforms. And it has a good integration with any other bigger platforms, because Minio, when people think about storage and easy way of integration, then Minio is definitely one of the candidates. So you can easily integrate this one, and we have used earlier for some of the purposes, like taking a backup at a Minio location, or using it as a secondary storage. So both in a primary and secondary use cases, Minio can be one of the really good option. So how do we set this up? It's very simple. It's a client server kind of an application. So wherein you set up a Minio, you can just this demo is like a standalone demo on Ubuntu system. So you can just install Minio on your standalone machine, and you can start the server by giving the server name. Once this is done, your Minio server will be up. Now you will access through client. So you Minio client is also available. Although I can show you other ways of operating on this Minio server. One of the way is through using the Minio client. So that also is we have installable. We can install, and we can also set the server, because this client can be used to connect to multiple servers. So you can add servers, whichever server you want to connect, by specifying its IP address, port, and some access keys. So where we can get the access keys during the demo, we can see. And then you do a operation on a Minio server. You create a bucket. Bucket is kind of a placeholder, or it is very similar to the directory in our file system, wherein you place the objects. So you have a bucket, and then you can browse through the server contents using some of the um, Minio client commands. So there is a reference about what all you can do with the Minio client. I have just attached the HTML. So all these operations you can sitting at the client side, you will be able to see. Uh, that's all I have with respect to context setting. Without wasting much time, let me just get into the demo. This is my server tab. So like I mentioned, I have just installed the Minio server, and I have started the Minio server. Once you start, this is started with the default. This is started with the default credential, that is Minio admin as a credential. So here you can see, like when you start, it exposes several endpoints. One endpoint is to access the console, and another endpoint is for the API based operations. That means when you connect from external clients, and not necessarily Minio client, if you have written your own client, S3 based client, also you can use this endpoint and fire the APIs and get the responses from the server. And this second URL you can use for viewing it as a dashboard, which is another user friendly way of checking the Minio server. So this is about server. And let me tell you how I set it up a client. So client is nothing but I just install the client library, and uh, and it is good to operate on server. So first, let us see when you fired a server. I just want to show how the server looks like. Okay, here only it is there. Okay. So this is the server. This is the port I was showing you. So when I open this browser, you can see this is the object store. where currently nothing is there. You can see buckets. So I will use my client and create one bucket on this server. So that's a command like mb, like it's like a mkdir. So this is for creating the bucket, and you can see like a bucket is successfully created. And if you also do like ls on this server, you can see this bucket is created. And alternatively, you can move to here. You can just refresh. You'll be able to see the bucket. So once you have a bucket here, alternatively, you can operate either on the client side or on uh, with GUI, and you can interchangeably use. Means whatever you created here, you'll be able to view there, and whatever you created there, you'll be able to view here. So now I just want to put something. So I have put an object inside this bucket. So you can see that this object is here. And if I do get 0, then yeah, I can see the same thing here. And all the CRUD operations can be easily performed here. Okay, so this is about the storage part and the CRUD operation part. And you can see there are a lot of things, I mean, on top of this, lot of provisions provided from the MinIO side. Like you have your own identity management system wherein you can create users, you can make them groups. Once you make users and groups, you can also control the access. So here also you can see like once you have an object here, so you can also share this object, download this object. So all those access control things are available for every object you place. And also it has a very good documentation with respect to operating on MinIO client. So these are other things like it also provides monitoring, performance, profiling. These are some of the advanced things on the data which you have placed here. So this is a gist of like what you can do with the MinIO and some of the CRUD operations which you can do. And you can completely operate on client using the command line. Everything is available. You can see when you try to delete this, since the objects are already there, it will tell like you need to delete the object you have pressed. So in that way, all kind of precautionary things, the respective warnings, necessary informations are provided so that you will be seamlessly able to operate. Yeah, that's a short demo about MinIO. So why we picked MinIO? There are, like Sanil mentioned, there are a lot of storages, software-defined storages available here, and they are open source based. The reason why we picked this, this is one thing which is easily installed and easily able to visualize, which that is the main reason we picked MinIO as one of the SDS example. Back to you, Sanil.
Okay.
Thank you, Sandra, for that. Yeah, I just want to maybe add a few more things here. Very good demo of MinIO there. So I believe, okay, maybe I think you can finish, then I can discuss it. I have some points, but I think let's just see the entire workflow of yours, and then I'll just have a few things to share. But yeah, let's go forward right after this.
Nivendra, can I continue? Finish it?
Yeah, you will finish it. Yeah, you can continue.
Oh, okay.
Please continue. Yeah.
Okay, so we have seen the demo. Now I'm sure that you are going to create one Minio object store on your laptop. And not only that, the beauty of that platform is that you can have a object store complete management with whatever storage you have in your infrastructure for your organization, maybe college or wherever, with any small group of people. If you have a public IP address or internal network, you can actually create this and manage your all the data as objects. Right? I think you can create it's, all the platform support is available, and even some of the data management features also supported by. Okay, now going forward, what we need going forward, what is our current situation? So we have, we talk about edge computing or edge cloud core that is on premise, because we are already out of on premise, right? We are in the cloud, we are in the edge, where on our all our handheld devices. So there are different domains we need to handle, and there are different kind of files. That's what we were discussing earlier, that file, block, and object. And there is a fight going on. File is better or not, block is better or not, object is better or not, right? So it is an unsettled, argument, right, to a great extent. And there are different kind of platforms, maybe like orchestration engine itself on enterprise OpenStack kind of platforms, in Kubernetes or container kind of thing. And now there are a lot of microkernel, micro compute engines are, researched. So there are different kind of platforms happening. Application, I don't need to tell the variety of the applications and the use cases. So what we need is that we want everything easy, right? We want everything easy. It has to, if I need file storage or block storage or object, it should work. If I'm deploying my application in edge or core or cloud, it should work. Something like that. So our requirements are endless, right? We want unified, and it has to be global and across edge, core, and cloud, and then across all the file types, and across platforms, applications, and use cases. Everything should work seamlessly. This is where our requirement is. So that's why all these unified storage platforms are becoming attention and traction. That's what the development is happening. It is going towards that. Now, this is one of the surveys we have done under Sora Foundation, the data and storage survey. If you see some of these points, the growth of the data is very, very huge. And now the multi-cloud, public cloud, and cloud technologies used for storage is becoming prominent. So I'm expecting this is done in 2022. If you do it in 2023, I'm very sure that this will go beyond cloud. It will be something like very much hybrid with edge compute and all these things. But public cloud is not a notion. The cloud, multi-cloud is not a notion. In production, people are using, I think, more than 72% of the companies, they use more than 2-3 public clouds for their services, application deployment. Then the other part is about data management, like security, data mobility, and things like that. So these are all important, and this is where things are moving, right? When it goes to hybrid, then you need more intelligence. It has to be AI-driven, hybrid data management across cloud, edge, and on-premise. So the fact is, data is growing, cloud is becoming very prominent, and AI-driven hybrid data management and metadata management are top trends in next 2 to 4 years. So if you are going into the storage domain or a data management story, it's no more storage domain, it's data domain. If you're moving in that direction, primary thing is about the hybrid data management and metadata. Metadata also, the key point is unstructured data, because most of the data what we are seeing today is unstructured, can't be put in a format or a schema. It's becoming very challenging because a lot of data sources are unstructured in nature. Your photos, your nature of photos, your data, text messages, video, all these things. So unstructured data management is going to be the key point and going forward. So challenges are already we discussed. It's like the data mobility and scale is becoming very high, and distributed heterogeneous storage, different kind of storage. When it goes to edge, it will be more variety there, because small storages for different use cases, it can be there. Distributed storage. So basically things are becoming hybrid. So the rescue is only with all the technologies. So you can see these two links. The first link is very interesting. It's called MAD. MAD is nothing but ML, AI, and data. it's a landscape. So there are a lot of projects with respect to ML, AI, and data connecting projects in that landscape. So based on my experience and whatever we are currently working, I feel there are two more things to be added to this. Two C's to be added. That is MAD to C. In the sense, ML, AI, data, cloud, and cybersecurity. This is going to be very, very important. And all the solutions which are going to come, all these technologies will overlap together to build solutions for our seamless application data management. Yeah, this is just one more information that, as I mentioned, we work in sort of foundation. We have multiple projects. It's completely open source under Linux Foundation. If you want to join, there are a lot of developers. We welcome developers to work with us. So you can use this Slack link to join. And as soon as join, how to contribute? It's very simple. You join, say hi, and I would like to contribute, and we'll be there to help you out. And I just added one good, nice book for SDS for Dummies from IBM. It looks very simple and nice, and it covered some of the cloud aspects also. So container, Caze, and all is covered there. That's all from my side, and back to Nipendra. Nipendra, you want to have something? Hello?
Nipendra, we cannot hear you.
You're on mute, is it?
Sorry, guys. Technology thing, right? Yeah. So, sorry, I was on mute. Yeah. So
I lost my power.
Thank you,
also.
Sanil and Sushant. Okay. Oh, is it okay? Thank you, Sanil, Sushant, for the demos here and that information. I think this is definitely going to be useful for the people who are in this particular webinar. But as we have seen that these webinars are being viewed by multiple people after they got on the YouTube. So I'm sure that as people are going to connect the dots from the beginning till here, they're going to really find this particular topic very useful. I just want to add a few more things to the demos what Shanta has given about Minio. So currently we have seen the Minio demo with respect to a single instance, right? I just want to bring it the context of the high scalability and how it is going to do in terms of Kubernetes, right? So because as we know with SDS, we want to have the scalability and we want to have the management of it to happen automatically. So how that can be done, just want to bring it few more points to it. And then, of course, we can close off. I'll just share my screen and just talk about that part. Let me just share my screen here. Yeah. So this is one of the documents which I am opening from the Minio website, right? So Minio, of course, what we saw right now was deployed on a single instance on a Linux machine, I believe. But then we can also deploy this Minio as an operator. Now, what is an operator in terms of Kubernetes? It is a combination of controller plus the knowledge of operations. So that is what a single term operator means. So think about, I just give an example of database. Suppose you take the example of database and you deploy, let's say 20 GB of storage right now. And now you have filled up, let's say 80% of it. Now, there should be a way by which we should be able to extend that 20 GB of storage to, let's say, 40 GB for our future use case. Now, the operator can have that knowledge where we can put up a trigger saying that if the storage is already filled, get more data, right? Get more storage behind the scene. That is the knowledge what operators can have. Now, once we are going to deploy this Minio or any kind of SDS with respect to Kubernetes, right? Or like other orchestration engine as well, right? So what you see here is we have deployed the Minio operator. And now today we are just, let's say, putting up 10 object in the Minio bucket. But tomorrow we would be having thousands and whatever number of lakhs or whatever storage going into the storage, right? Now, who is going to manage the scalability of it? So, of course, the operator would talk to the underlying your cloud infra as well to get more storage, but all of these things would be seamlessly connected, right? And then we can also do it the Minio with the different tenants. For example, you have different customer of yours, right? And you want to manage different buckets for different customers and all those things, right? So that where the Minio can again shine in. So that way, we can, once you put these operators and CRDs of the storage on Kubernetes and connect with the underlying cloud provider's API is called, right? It just becomes massively scalable solution, correct? And that is what the SDS, all of them are trying to do, that plug in or build those CRDs or that intelligent and club into Kubernetes. And then with Kubernetes and the underlying infra, we can scale and we can manage it on its own. That is where I believe the world is going towards. So yeah, that's what the small information from my side. With that, I think we are good. Do you guys have any questions? Please put them in the chat. I'll quickly do a poll on this to find out how you find this particular webinar here. Okay, so hopefully I said the right thing, right? Sushanth and Sanil, about Mina and what I just mentioned about operators.
Yeah. Actually, right.
Yeah.
So I was just in a dilemma whether we have covered the Kubernetes aspects or not. So I purposefully did not include that aspect
No,
so that
that
standalone
is,
is easily understandable. But you covered
yeah,
all
of
the
course, that is
things.
that is. No worries, no worries. No, no, that is it happens. So I know that because of, I mean, I know that that kind of sometimes it becomes difficult to understand there. But yeah,
In
I
a much
think
bigger.
all good. Yeah, I know this with the limited time, you know how much to cover, and then we kind of work on that, right? So I think we are good for now. So I think all of the
Right. I think we
participants
are
who
on
have
time.
put up poll, yeah, we are on time. Because of time, I think we have kind of took it like a bit shorter here. But hopefully, all of you have got an idea that what is an SDS and how it is going to change the way the things are happening. And then what Sanil said earlier, right, about about the how it is going to grow, the data, right? With AI, ML, and analysis data, whatever is going to grow, that's going to really be huge. Like the requirement of that data management is going to be huge, and it is not going to be possible with the regular solutions. We need something on the software, right? Sushanta, can you just maybe come online, start your video maybe? I don't know what happened. Yeah, he's here. I'll just take a quick screenshot of all of us so that you know that we are all here. Yeah, thank you. And the next webinar is going to be at the month end, I believe. As the questions is going to be on the object storage. So I think what we covered, Binayo, partially that maybe, I don't know. I'll work with the speaker to bring the right example of the object storage in the next session. Thank you again, Sanil and Sushanta, for this particular webinar. Again, getting time out with a busy schedule and doing it for the community is not easy. I'm sure about that. And then whatever time you have put up, really appreciate that. Okay, I think one question is there. What are some challenges in using SDS in your product? And what are some of the workaround solutions? Have you tried out with those? So, Sanil, can you take that? That's okay.
Yeah. So challenges, you're able to hear me?
Yeah.
Yes.
Okay. So challenges, the first challenge today the first challenge will be the selection of SDS, because which solution you will use. That's going to be tougher, because you talk about Minayo, it's an object store, then you have Zenko, you have different solutions. Whether you want to use it SDS kind of solution, or maybe when it comes to Kubernetes, like Nipendra was mentioning, whether we use the traditional like Vinayo based solution, or maybe we use Caze based solutions, or the selection part is one of the challenges. So how to overcome this challenge? One is that you need to know what kind of use case domain you are in. That's very important. So you need to define your SLAs, like what is your performance, what is the kind of data you are going to handle it, whether it will be completely an object kind of thing, or whether you need to handle multiple different heterogeneous kind of a data, things like that. So these we need to define these things before you select SDS. Now, Again, the next challenge usually, and one of you asked also about the latency and performance part of it. The performance is one key aspect when it works, when we try out for hybrid kind of solutions. So this is very important to address. Again, here also you need to know that what kind of performance you need. It's not that the highest performance is the best performance you need, right? So that is also another thing. And workarounds, as such, I don't have any specific experience about workarounds because we just select what is needed and then work with that. And in our case, we use some of the components from Soda for our experiments. Of course, we have used LimStore, we have used Senko, we have used OpenEBS kind of solutions. I hope I answered question to some extent. Provider that can provide all three major. Yeah, block storage, block object and file. I think you meant block and object and file. I think most of the top vendors are started supporting this. AWS, of course, support because in Soda we have a multi-cloud project which handles all these files in a unified way, file, block, and object. So we support AWS. That way, I know that AWS support it. And Ceph also support Ceph. Most of these solutions like Ceph it supports and this true NAS kind of thing. I think it's mainly on the file, file and object. Yeah, block object file in open source Ceph is a good example.
Okay, I think we are good. Thank you again, Sanil and Sushanth, for your time. So yeah, I think see you guys in the next webinar, and hope you're finding this webinar series useful to kind of help us understand all the building blocks. So eventually we can build our own cloud. So things we are building up, and towards the end, definitely we'll see one cloud which will build from a couple of physical machines. That's what we are planning. Yeah. Okay. See you guys.
Okay. Thanks,
And thanks for
Nipendra,
time again.
and thank you all for joining.
Bye.
And thanks for
Thank
this.
you.
Okay,
Yeah.
thanks. Bye-bye.
Thanks for joining. Thanks for the opportunity.